With nothing more standing between our first keynote speaker, I want to proudly introduce Dr. Dan Arvizu, Director of the National Renewable Energy Lab, and let's give him a warm welcome to Madison, Wisconsin.
Thanks, Tyler. Appreciate that. It's a real pleasure to be here. So first of all, let me just say thanks for the invitation. Both Carl and Tyler for the invitation to speak. Joe for the warm welcome that I got this morning. This is one of those events that I absolutely am delighted to do because I get a chance to talk to a lot of folks who both are very interested and in many cases very passionate about the same things that I'm interested and passionate about. I will admit that when I requested the trip to come to Madison in January, I got essentially no concerns from the Department of Energy regarding being a boondoggle. So it's, I'm good on optics here. I'd like to come back in the summer when it's nicer, perhaps. Also, I didn't want to say something that was kind of spurred by the earlier comments, and that is, you know, in Colorado, the voters actually were the first state to actually have the voters vote in a renewable portfolio standard. And that spoke volumes. I think, again, that I was impressed by the amount of support you have here locally for that, because it's a tremendous instrument. It really does focus. I know our utilities weren't crazy about it when it first came out, but you know, today they're on board. And we've got one of the best partnerships with Xcel that I think we've ever had. Ben Falk, who's the CEO of Xcel, the broader company, is on my advisory board. We spend a lot of time together, and we work issues and problems together. And so, you know, Colorado was at a 30% RPS. It was voted in at 10. We increased it to 20, and then we increased it to 30. All by 2020, we'll make it early. It really is, and we'll get beyond that. I find that once you get into it, it's much more palatable, and there's a lot less concern about all the bad things that can happen. You can manage it. It can be done with. So I'm going to start there. I've got a lot of information, and I really only have a couple of points I want to make. I'll put this on our website. You get a chance to look at it in greater detail. There's a lot. It's packed with information, but really it's designed to do a couple of things. One is to let you know there's a lot of stuff going on. Second, that there is tremendous potential, and in the third kind of key point is we need to invent the future that we want. Because frankly, if we stay on a path that is the path of least resistance, that is the path that's going to be the least controversial, that's going to have the least amount of energy injected into the pathway, then I think we will get to where we want to be much later than we need to be. I talked to the folks back in D.C. a lot. In fact, on the world community, pace of the transformation of our energy system does matter. It does matter how quickly, for the reasons that have already been stated. You know, we get locked into other generation commitments, and they last a long time. And if we want to make a difference, you got to start now, and you got to be fairly aggressive. So I'm going to set some context, kind of big level, talk about the promise and some other things, and then I'll leave some time for questions, because I know there's always a number of questions regarding best practices, what are the other people doing, and how can we take advantage of all that. So let me start with kind of big picture stuff. The first thing I'll say is, in this particular context, renewable energy growth is dramatic, and it's pervasive. Literally incredible amount of investments being made. We've now cumulatively invested more than $1 trillion in terms of renewable energy technologies globally. Now, most of that's not in the U.S. Most of that's globally, but it's happening. It's happening at double-digit over compound annual growth rates. There is a changing energy profile both in North America and in Europe. Our energy demand going forward is actually going to go either going to be flat or going to go down. We're no longer in growth mode in terms of new energy demand. We will have to refresh our infrastructure and some other things that are necessary. So investments will be made, but frankly, we're flat. It's really growing, and this little graphic here on the right that you can't see very well is an ExxonMobil projection out to the year 2050. The big piece of growth is all in the emerging economies, primarily China and Asia, but soon after it'll be South America, it'll be Africa, a variety of other places in the world where there'll be tremendous growth in terms of energy demand. The projections are that most of that demand, if we stay on the trajectory that we are now, is going to be coal. I mean, it's surprising to a lot of folks, but it's going to be coal. There's a tremendous amount of renewable energy being deployed internationally, but frankly, the big piece is going to be coal unless we do something different. So that's kind of one of the cautions that I provide is that we can do all we want locally, but globally we've got to be thinking about that in a much more holistic context. Fiscal challenges. So it's all about the money, it's all about the budgets, and frankly, the entire world is running through a fiscal crisis of sorts. So it's not like there's a whole lot of new, expansion of our financial situation. It actually is constrained in a lot of different respects, and that does affect public policy. So that's the next big thing. And then, of course, in the last 5 years, what you hear about is the natural gas renaissance and all the stuff that relates to. There's still some uncertainty there. It can be, some people always ask, is it friend or is it foe? How should we view natural gas relative to the renewable energy community? And I think the most accurate descriptor that I can put on that, it's a frenemy, okay? It could be a friend, it could be an enemy, all right? In fact, it's an opportunity for us to do, I think, what we need done more quickly. I think it can be an enabler, but it certainly is not the end all. It's not where we want to end up is, a future that's dominated by natural gas, which is what some would suggest. There is, in fact, I think, a need to have a transformation of our energy economy. We need to define the attributes of that transformation. In other words, what do we want in the end? And then we ought to be technology agnostic. Frankly, renewable energy will play a much greater role than anybody anticipates, in my opinion, for the reasons that I'll express here momentarily. But natural gas is a player, we got to deal with it. And in fact, I think it's an enabler and it can be a very important element of a transition. But we do have to manage it. We cannot just let that happen without deliberate policy and otherwise regulatory sorts of approaches. Finally, infrastructure. We've got an aging infrastructure in this country. The emerging economies don't have infrastructure that they're going to build. There's going to be a lot of investment. And the question is, on what? What will we invest in? That's really the key point. All right, so I'll fast forward through some of these. Here's kind of a picture of how much renewable energy is being deployed on a global scale. So, big number there on the right-hand side, 480 gigawatts. All right, now that's half a terawatt. All right, I can remember when we were celebrating deploying a 10 kilowatt system. All right, this is not that long ago. In my lifetime, obviously, when I was a young engineer at San Diego National Labs, we were celebrating 10 kilowatt systems. Now we've graduated to megawatts, we've graduated to gigawatts, and very soon we'll be at terawatts. This is a lot of energy. All right, this is no longer a curiosity, a niche. This is a mainstream technology and can be and will be. Most of that is not in the U.S. You can see here down here by country. The U.S. is pushing 86, probably close to 100 gigawatts soon. All right. Globally, we have 100 gigawatts of solar, which is amazing to me. That's primarily solar PV. We have 300 gigawatts, that's 300,000 megawatts of wind. It is no longer a niche. I mean, these are huge types of numbers. And for those of us that started in this community, in the mid '70s. This is major progress. If you just take a snapshot and say, what have we done? Phenomenal. And in fact, it's just growing from here. All right, so that's huge. A lot of investment, and I won't go through the details of this, but what you can see is a lot of investment primarily was in Europe for a while, all right? And that's kind of starting to taper off. It was in the U.S. Over here you see in China and in Asia, it's really starting to take off. There's a tremendous amount of investment in this sector. So these concerns about whether clean tech is alive or dead or whatever you hear on 60 Minutes and those things. Okay, so they ought to get educated because in fact there's a lot of stuff going on and we need to at least recognize what the facts are. All right, the facts are it's happening. All right. Now here's the next big piece, which I think is pretty important, and I've been part of probably a dozen what I would call global assessments of what is the potential for renewable energy. When I first started in the business, I'd go to Congress and I'd get the two major questions. First question is, all right, so when's this stuff going to be real? And the second question is, and how much can we have? I mean, how much is realistic for us to actually? So I got tired of answering those questions. My answer to those is it's already real. It's, you know, $500 billion plus now dollars worth of investment. More importantly, the answer to how much can you have is how much do you want? Because it's not a question of technical potential. The technical potential is enormous, and that's what these studies say. I've been again part of a number of those, IPCC and a variety of others. All right, so let's kind of get the facts on the table. You can have as much as you want. It's kind of the issue. There are a tremendous number of resources that we can tap. All right, now at NREL we did another thing, was we convened a very large stakeholder group, and we did this thing called the REF, the Renewable Electricity Future Study, which has now been quoted kind of fairly liberally. But what that study was not a prediction, not a projection, but in fact a scenario analysis on if you chose to do 50, 60, 70, 80, 90% renewables, could you do it? And if so, what would it look like? What would you need to do to make that happen? We actually focused the study on 80%. Can you do 80% renewable energy deployment in this country, meet the loads of 2050 of this country, based on our projections of what the profile looks like? We have utilities, regulators, vendors, all people that really know about how you deploy electricity, and the conclusion of the study is it can be done. The conclusion of the study is if you wanted to do 80%, you could do 80%. Again, not a prediction, not a projection, but it is in fact an analysis of what can be done. It's a very, very, very comprehensive study. It's a number of volumes. It's on the web. You can find it. We did similar things for fuel because clearly transport's important, and not so much how much fraction can you get from renewables, but how much energy is required to do the mobility of this country. And there's a lot of ways in which you can slice that demand, mode, and fuel. All of those things suggest one pretty key element, which is we can be a whole lot more efficient than we are today. We can with a minimal amount of fuel do almost what we have encouraged or otherwise will do in terms of a mobility sector. So the analysis suggests tremendous amount of potential. Okay, so a lot of stuff going on, a lot of potential, and so now we've turned our attention at our national lab, and specifically this is the national program, not on can it be done. I think we've answered that question. The question is, how do you do it? What do we need to do to make that transition from where we are to where we need to be? That's the hard part, because as you know, this sector is very complex, it's very dynamic, it's very cyclic. Things go up and down, and I've been through a number of cycles, and you get all excited about things are going to be moving, and all of a sudden, you know, something changes, the price of oil drops, natural gas, whatever it is, all of a sudden now it's all right? And in fact, you know, on the president's agenda it moves up and then it moves down, and you know, president after president, I mean, since Eisenhower has been talking about energy. This is not new by any stretch. And yet, we haven't really made the kind of progress that we would like to make. I mean, today, we have, the good news is, from 2002, in the last dozen years or so, we have increased our non-hydro renewable energy electricity generation, not capacity, generation, the actual amount that we produce, from 2% to 6%. All right, you add hydro on there. Hydro's like 7%, so you got 13%. So 13% of the U.S. electricity is now essentially generated from renewables, and that number again can be much, much larger depending on what you choose. All right. Well, so where is that all happening? So there's a lot of studies and lots of things on how you might approach this. Much, you know, I'll get back to policy in a minute. This is what's happening. It's happening at the local level. What's driving renewable energy deployment in this country is the state-by-state mandates or otherwise the incentives that occur there. And you can see a lot of people doing lots of things. If you want to know this more specifically, go to the Desire USA.org website, and it'll give you all this information. This is directly out of that. It tells you kind of what's happening, where we're going, lots of folks doing lots of stuff, but clearly what the message is, it's happening at the local level. We've done some studies that say, okay, so what happened if all that got satisfied? Then what would happen? You know, do we expect it to continue or what? Well, it depends. It depends on several different factors. And I think the new factors have to do, and this is where our focus is these days, and that is on integration and scale. It's no longer about getting it into the market. This is now about how do you incorporate it into our existing system, making the transformation that's necessary, and then scale. All right. All of those things will, I think, lead to a much brighter future and ultimately get to that outcome that we're looking for in terms of what's possible. All right? Well, this is a pretty important slide, and I got a lot of information on here, but a couple of things that are important. So you need to be dealing with a whole new paradigm on how you deliver. This is primarily electricity focused, but it's also true in the other sectors. Variable supply as well as variable load. The utilities know how to deal with variable load. I mean, we're plugging stuff in and out of the system all the time. What is harder is what happens if you put in a whole bunch of, say, the so-called variable renewables, solar and wind, where the supply is variable, and it's maybe not predictable the way you like it to be. Well, now you need some other things. You need demand-side management, you need a variety of things that relate to storage and two-way power flow, you need data analytics, you need a whole bunch of new technologies that are going to enable this new future. To me, this is really exciting. When I talk about jobs being created in this sector, it's not because we have more installers putting rooftop solar on. It's because we've got a whole new business model that allows us to have innovation run rampant like it does in the IT industry. This is really the future. This is really where things are going to change, and it's going to change because the business model changes. We can't have utilities only getting paid when they generate more electricity and when they build new power plants. That model doesn't work in this environment. We've got to change that whole thing around. This is exciting to me for the various reasons that I've got on the slide. One of which is changing roles as consumers, utilities, investors, power producers, vendors, and regulators. The role is, we don't call ourselves consumers, we call us prosumers. We're producers as well as consumers. And we're not, and the utilities, maybe their model isn't selling electrons, their model should be selling services, business services, energy services, capacity factors, ancillary services, things that make the grid stable, things that heal the grid. A variety of things that really are very, very different than anything we've done and seen before. Now that's I think, the exciting part, and that's really what we ought to be talking about. So we keep arguing about stuff that I believe is incremental improvements to an existing system when in fact we need an overhaul of the system. And this requires everybody to pull together. We need national policy, we need a variety of people who catch the vision that there's a pony in here, that first of all, it's in our interest that we have a sustainable energy system. It's in our interest that we have an affordable, reliable, safe, and inherently benign environmentally system. All of those things are in our economic interests as well as our environmental interests, as well as our security interests. So all of those things to say is what I think the national program ought to be about. This is my sermons to the administration and our new leadership at DOE is that really it's the role that the federal government plays is a small role relative to what is required. This is inherently a private sector market deal. All right, even though it's highly regulated, it is about private sector investments, not public sector investments. I think the public can help, but I think we need to leverage the investment that the federal government makes, because frankly the federal government doesn't have that much money. When you do what we do, we need to be able to reduce the invest of private sector investment. To me, that's the mission of our laboratory. Reducing the risk of private sector investment to help this transformation occur more rapidly. Again, let's define what we want. We do care about carbon. I've been told by a number of people in the administration. I used to say, if we care about carbon, and I got corrected by John Holdren, who's the president of the science advisor, he said, Dan, we care about carbon. Okay, just so you know. That's okay. All right. So, but for those who might not, I'll say, if you care about carbon, then you should include that into the equation. But it's not exclusively about carbon. It's about economic development. It is about a new future that is in our best important national interest. Okay, I'm going to move very quickly here because I think the other thing I want to do is to say there's three pieces. There's a technology piece, there's a market piece, which has got to do with finance and how does the money flow and capital and all that stuff. And then there's a policy piece, which says, we've regulated our energy sector, and like it or not, that the accumulation of many different policy actions that we've taken for the last century has given us what we've got. And frankly, it does not do what we need. So we need to rethink all that. So all those things are important. I come at it from the technology side. What can the technology provide? And the technology is only a piece of it. But here's the exciting piece for me, and that is that technology actually has a great deal of promise still left in it. Many people say, well, we've already invested, it's kind of there, we don't need to do anymore. And I say, hogwash. I mean, frankly, when I started in the business in the mid-70s, I was at Bell Labs. I transferred to San Diego to start solar programs. It was great stuff. And we didn't know what we didn't know at that point. So we were a bit overly optimistic. But I'll tell you, what I've seen now, what I saw in the laboratory then was exciting. Because I could say, oh, these are really cool things. Much of that now is today's commercial product. All right? What I see in the laboratory today is orders of magnitude more exciting, more innovative, more creative, more potential than what we saw literally 30 years ago. I mean, this has expanded, so I'm just mind-boggled by how much opportunity there is in terms of new innovation. You unleash the market forces, and this will take off. I'm convinced of that. All right, so lots of things to talk about here. I'm just going to say a few words about some of the key technologies because it'll just give you a snapshot. I'm not expecting to take a lot away from this, other than these are kind of some of the things that we talk about when I give technology briefings. A lot of stuff going on here. Costs are coming down. Here's the part, and many of you know Larry Kazmersky is a good friend of mine, and this is the so-called Kazmersky chart. But some of you love it or hate it, okay? And my technical people really love it, okay? My policy people hate it. Well, here's the thing you take away from this graphic. From this graphic this is time along the bottom, and this is technology progress on various material systems in photovoltaics, right? And everything is up and to the right. That's the key point to take away. Everything is up and to the right, moving rapidly, continuing by all these various players. In fact, this is the Kazmersky chart. If you go to this chart on our website and actually hover over any one of those data points, you'll get a whole ID curve. You get, essentially, you'll get all the technical parameters of every one of those data points. These are what we call champion efficiencies of material systems that NREL has actually measured and validated. Okay, so it's a great graphic. Now, for the policy folks, here's the part that I want to really focus on, and that is okay. So you got in all these material systems, there's concentrated PV, there's crystalline silicon, there's microcrystalline silicon, there's copper, gallium, selenide, cadmium. There's a bunch of technologies here. What you see here is a gray bar. Okay, the gray bar is if you do kind of basic physics, you say what's the technical potential of that material system, and what you see it's a big bar, right? The red bar is actually the data points on this chart. That's what's the champion efficiency ever demonstrated on a real device under real conditions. Okay, that's that number. And then the yellow bar is the commercial systems of today's technology. Okay. Now the takeaway here is we're about half of what our potential is. All right. What that tells me is, as a researcher, is wow, there's a lot of potential here to do some great science. There is a lot of technology innovation opportunity to improve this performance. So essentially what you can say is that you can double the efficiency of these things. If you double the efficiency, you'll really reduce the cost. Right, so the opportunity space is huge. That's the point to take away from this thing. All right, so wind technology, I know it's one of these technologies. I'm a mechanical engineer, and one of the things I'm always amazed by is how do these 400-foot tall, 120-meter wingspan things work? Crying out loud. When I started in the wind business in the late 70s, the largest turbine we had was 1.8 meters. Okay, that's like 6 feet. Okay, and I could that was how big it was. Well, so now you put two 747s in the middle of the rotor swept area of one of these machines. Absolutely mind-boggling. Tremendous amount of opportunity here, and in fact, some of the programs that we have at the laboratory are about how do you do wind at half the cost. I mean, the cost of wind now is in even what I would call low wind profile areas is like 6 cents a kilowatt hour. And in some high wind profile areas, like in upper Wyoming and probably parts of Wisconsin, you're down at 2 or 3 cents a kilowatt hour. I mean, there's some real potential here. And in fact, one of the things I was intrigued by, I got a note last night from Dave Danielson, who's the Assistant Secretary of Energy Efficiency and Renewable Energy, said, and he goes, I saw this article where, we had this big coal snap, and there was a lot of thermal units that went offline because of the coal. That all of the wind turbines that were operating under those conditions were operating at 100% capacity factor. That tells me that we've got a value in this technology area that we really haven't quantified. In fact, I wrote an email to my folks last night, and I was looking just a second ago to see if I got an answer. And I said, have we done any studies to quantify the positive attributes of how these systems perform? When the rest of the system doesn't perform so well. And the short answer is no, we don't have that. So we're going to get it. So you'll hear more about that later. All right. So I learned something today. Biofuels. I'm probably as excited about biofuel, product technology. Is there anything there? When I first started again at NREL a few years ago, I've been there now 9 years. We had just started the biofuel program, and it was at that point very Edisonian. For those of you that are familiar with Thomas Edison, that was experimental. Okay, so we had people going to remote parts of the world and doing cultivations of algae in certain crazy conditions to understand better what biochemical processing could actually do. We have come a long way. We put a lot of Department of Energy money into looking at biosciences, biotechnologies, and what I'm telling you is what we've done is we've begun to infuse some science into this arena, and all of a sudden now we're getting a lot smarter about how to manage these technologies. Tremendous amount of what I would call new breakthrough science yet to be had in this particular arena. Biofuels, biomass, huge opportunity, I think, to be a contributor. It's not the end all, but it is in fact a fairly important and major contributor, especially in the regional and local economic areas. I mean, when you're looking at what should a region do, the first question you're going to need to ask is, what are my resources? What am I trying? What can I tap, and how does that comport with my business profile and all of the needs that we have, economically, and our goals and the things that are required for that. Biofuels, biomass, those kind of things will be a big part of that. So all that to say, there's a lot of good stuff happening in that arena. I do want to focus on the geothermal. Obviously, I tend to not put as much emphasis on geothermal. Geothermal is baseload technology, and all the stuff we've done with fracking and horizontal drilling and all those kinds of things actually applies. It applies in this arena, and much of that technology, by the way, when I was at Sandia Labs many years ago, we did on the basis of enhanced oil recovery and geothermal. There's a lot of synergy there. Anyway, I think there's going to be some great promise there as well. I did want to spend some time on energy efficiency, because one thing that I frequently said, we tend to focus on the generation side. We don't tend to focus on the end use side, and NREL actually has a mission objective around energy efficiency as well as generation. And the part that I would suggest to you is important here is our energy system and our end use is so incredibly inefficient. Again, because we started down this path 100 years ago when we thought energy was going to be plentiful and that it would never be an issue relative to how much we use. Well, it is an issue, and that's changed, and we haven't changed our behavior. So we have an incredibly inefficient system, and buildings is one of the most places where I think you've got an opportunity to do things much better than we have in the past. And so this is a profile of, for buildings, we use about 40% of the energy of the country goes into buildings, 20% is in residential, the other 20 roughly is in commercial. If you just look at how we use energy, one of the things that I show here is in the commercial buildings, almost 30% of the energy we use in commercial buildings is lighting. You just lighting. And so when we had the opportunity to build a building at NREL a few years ago, after we finally got some attention from Congress and they decided to invest in our infrastructure, I asked our folks, I said, if we're the National Renewable Energy Laboratory and we're out preaching and telling everybody what they ought to do, shouldn't we also be doing kind of what we say we're going to do? So we can't, if we had demonstrated here, then we're really not doing our job very well. So one of the things we did is we purposed to make the world's most efficient building, which in fact we have done. So now in hindsight, I can tell you the story. It was a little bit more dicey when I was trying to do it than now when I can say we've already done it, right? So the first thing we started with was how do you make a building as efficient as possible? And so we looked at how do you use energy. One of the things is lighting. And so what we gave it to the engineers and said, so what would you have to do? Well, in Colorado, you can throw daylight, you can throw sunlight about roughly 20 meters. That's 60 feet. So we decided to make the envelope of the building no wider than 60 feet. We got 3 quarters that are 60 feet. That's up the upper left-hand corner is our building. That's the envelope of the building. So once we defined the envelope of the building so that we could get to 100% daylighting, then we gave it to the architects and said, make it pretty. Okay, normally it's still done the other way around. The architects do something very, really, flamboyant, and then they give it to the engineers and say, so make this work. Well, so we did it the opposite, right? With all due apologies to the architects in the world. Right? So it doesn't look like, essentially, it's not going to win any aesthetic prizes, but it is functional. Okay, so we have 1,350 people that live in that building. So ultra efficiency. That's the first thing we started with. We put 2.5 megawatts of solar panels on the roof. That building now is net zero energy. It generates as much energy on an annual basis as it consumes. Now we did a lot of things to make that happen. Ultra efficient, we own generation, we have, in fact, we give our employees an energy budget. So by the way, we have a data center in that building as well. So the interesting piece is that you get 70 watts as an employee. Well, 70 watts is not very much. You know what your laptop by itself is 300 watts. So how do you do that? Well, we took everybody's laptop away, first thing. So we got a little nervous. But then we gave them a 15-watt LED monitor. We gave them another 15-watt thin client virtual computer. Essentially looks like a laptop. All right, and it acts like a laptop. You have the thing done centrally in a server. And you can do that remotely. It's actually new technology. It's good stuff. We didn't allow people to put the little space heaters underneath their desk, where you can get a little bit of control, like that stuff. We downsized the HVAC to the point where it was so small relative to the building that it didn't make enough noise. We actually put automatic or artificial noise generators in the floor so that you could kind of hear like air noise, because otherwise it really feels like you're in a tomb or something. So, and you can actually adjust how much noise you like. I like a lot of noise, right? I crank mine up. But you can have local stuff, and we have occupant behavior, essentially, that is now monitored, and on your desktop, it tells you how the building is performing. A tremendous amount of things. Now, here's the best part. The best part is, I was given a budget of $300 a square foot to build this building. We built this building for $259 a square foot. With the solar panels, $286 a square foot, less than a building built to code in our region. All right? So we got everything we wanted at a cost less than a building built to code, LEED's Platinum, and half of the energy consumption of the LEED Platinum building. And I've got 1,350 people that are pretty happy in the building in which they reside. It's very functional. I have my office in it. There are some things we do differently. But in fact, it can be done. That's the key point, is that it can be done. And the point is, and I get a lot of criticisms of folks who say, well, so that's great for all the new stuff, but what about all the old stuff? Well, clearly, there's the point. But I would offer the following rebuttal to that criticism, and that is, if we know we can do it, why don't we do it? And that's just a matter of will. I mean, it's economically in our best interest to do it, and yet we don't do it. So all those things I think are important. All right, so I'll go on, and I just have a few words about transportation. Transportation, similar thing. We finally have at least a CAFE standard that the president has announced a few years ago, that we're going to double the energy efficiency of our vehicle fleet. We can do better, actually, but this small steps are good. Let's do this. A lot of other things that can be done, and I think we're only beginning to scratch the surface. We really are. Energy efficiency really is a low-hanging fruit, and yet we simply don't. It's not glamorous. It's not sexy. Whatever. We don't focus on it. That's the stuff we all ought to be doing, and there really isn't a reason not to do that. Again, systems integration. There's a lot of stuff that can be done here, and I think one of the things that I'm excited about is this idea that in order to satisfy those who are concerned, and utilities have a legitimate concern that as you ramp up, intermittent renewables, that it causes some grid stability issues if you don't manage it. Well, and again, we're operating in an old paradigm. I mean, we need to think about what's the new paradigm. So one of the things that we've done in our lab is we have a new facility called the Energy Systems Integration Facility. It's $135 million appropriated dollars to make that work. And it's a partnering facility so that utilities can come and see how this all wires together before they actually do the experiment on their real system. Okay? With our public policy, we're forcing them to do things sometimes that they're way outside their comfort zone. Now, some of them are resisting inappropriately, but those that are receptive, I think, have real challenges, and we need to acknowledge that. And so we've got a facility where they can come and kick the tires, new inverters at the megawatt scale. This is a big deal, and with a lot of opportunity. In fact, the new Secretary Moniz is going to put some new money into this as a program, and we're going to do partnerships, and we're going to look at what are all those technologies, those new power electronics, power flows, data analytics, a major new inverter type technology that helps us do this integration a lot more deliberately than we would have in the past. And we're not going to run those experiments in real time, let the grid go down. We're actually going to do this in its virtual environment, and then that will help us make the policy decisions that says, okay, this can be done. Let's get on with it and change those business models and do the things that allow them to make those changes that are necessary. And there is, in fact, not just electricity that needs to be done, but you need to think about this in the context of all the other technologies, or infrastructure, the thermal infrastructure, the fuel infrastructure, the data and communication infrastructure. This is a very data-intensive future. This is true of all kinds of businesses that's going on in the marketplace. But this is a new reality. The new reality is that everything's going to be smart. There's going to be lots of data communication, and there's going to be lots of control, and a lot of other both problems to be solved and attributes to be harvested that are going to provide us great value for the future. And I think all of this requires a level of thinking and a level of sophistication that we've not seen before. Our system is not very smart, and we need a system that's pretty smart. All right, so let's get knowledge workers. Let's do the things that are necessary to make all this stuff happen. We've got an economic driver, we've got an environmental driver, we've got a security driver. Recognize that this is, everything that we're doing in the future is going to have cybersecurity and a variety of other things that are part of both a vulnerability and an opportunity. And I think we need to manage it. We're not going to just avoid this, okay? This is going to happen to us whether we like it or not. Let's get on with it. This is in our national interest to make these things happen. So, just a word about Wisconsin. Look, I know that you've gone through these ups and downs. I think you're well positioned. First of all, you got a crowd like this who's enthusiastic about the nature of what we need to do. I think that's a real positive. You build on that. I'm meeting with our governor next Monday regarding economic development in our region. I've met with Jerry Brown in California. I've met with other governors of other states where this is on the agenda. This is a major deal. And I think you're in a good position. You've got some starts. You've got the vision. It's a matter of will and recognizing, let's talk credible stuff. Let's not overhype things. That doesn't help us. But let's not let those who are going to resist carry the day by by throwing out misinformation and a variety of other things, which happens all the time. Let's get back to this not being a partisan political issue. Let's get back to this being in our local economic development interest, and we're all about this. This is the will of the people. Let's go make this happen. It's in our interest, and I think there's a lot of reasons why I think that'll work. So, in closing, I think we need to continue to invest. We're not going to harvest that opportunity by the investments. We need to invent the future we want, access to capital, partner on global scale, and just keep doing what you're doing. I think look to us at the national program to provide you with additional tools and things. But for the most part, I think there's a lot to be accessed. So thank you.
We do have a microphone in the middle of the room, and we can walk that around too. We have time for maybe 3 or 4 questions. And Dan will be here till around 2 as well. So I saw Gus first. Yeah, I'll repeat it. So the question was about the investment in the distribution lines to carry power to the users.
A big, I think an important question. So the short answer is we haven't done much, and in fact we do need to do a lot more. California's thinking about moving from a 33% RPS to something greater, as much as 50%. The only way they'll do that is with new distribution networks. So if you do have local generation, which I expect will happen, you do need to have smart distribution. So it's not just that you be able to get the power with power flow in one direction. You need power flow in 2 directions. And that really is a whole new type of technology. So as we think about investments and improvements in distribution infrastructure, we need to be thinking about it being smart as opposed to it being the one-way power flow, which is what we have now. And then we put kind of voltage support kinds of things at the end of a line. Frankly, we've got PV generating energy back in, and all of a sudden you got voltage spikes in areas where essentially previously you had voltage droops. And that, we don't have an infrastructure that is accommodating that. So what I'm suggesting to you is we need investments in smart distribution infrastructure, and it ought to be a priority. It's not just about transmission lines between big power plants anymore. It's about this other piece. And I think those who are more progressive, and I'll again point to California, I think are already thinking that way, and they've got included in their rate base out through the year 2020, major improvements, something like 2.8% per year capital investment in distribution infrastructure. It's an important piece.
We'll go to Sandy, and then we'll come to you, Tom.
I guess I don't quite on a phrases question, but it's towards education. And University of Wisconsin is going to be doing the Science Olympiad Invitational next week that I'm helping with. And there's not any sustainability or enough sustainability in that. I've been trying to talk about energy and explain to lay people using bike machines. And I find it difficult that for people to understand the terminology, how many kilowatt hours, calories, and I think that the NREL can be very helpful in that and provide educational material to the Science Olympiad and other educational venues so the public can understand the questions and the answers that you give.
That's a great point. I can't overemphasize the importance of education, and particularly STEM education, because the next generation, the workforce of the future, is going to have to be literate, much more literate than even our generation has been. One of the other roles that I play in my spare time is I'm the chairman of the National Science Board, which oversees the National Science Foundation. And one of the things that we talk about there is STEM education, and how do we do that? And we've included an energy component, because I think it's such an important piece of our future that's got to be in there. And so anything that we do at the grassroots level, please let me know, and I'll be pleased to try to continue to champion that. It's a very important point. Thank you.
Hi, Tom Mayer with the School of Business here in Madison. One of the areas that you didn't talk about was storage. And in Wisconsin, we have Johnson Controls, we have ZBB,
Right.
we have a number of companies that are hopefully cutting-edge companies as we look at storage. Can you talk about what you guys are doing with storage, what you're seeing as far as trends, and where our companies might be able to position themselves in the future?
Great point, and I'm going to make sure I don't miss that next time I speak. Storage huge. Two things. In order to deal with high penetration renewables, you need one of several things. You need a larger, what they call energy imbalance area, so that you need better diversity. You need demand side management, so that you can manage the load piece as well as a business value proposition, and you need storage. And when we have 6% of our energy generation from high penetration renewables that are variable, it's not so much of an issue because our systems can kind of accommodate that. Much beyond that, when you get to 10, 15, 20%, no longer can you do that. You really do need a storage component. Now, number of different storage options. We underinvest in storage like we underinvest in a variety of other things. Carbon capture and storage is another one where I think we underinvest dramatically. It would be a game changer if we could do it. The problem that I have with storage is it is really costly. And in electrochemistry, I used to run an R&D program around batteries and technologies. And the technology progress is really slow. Most of the advances we made in so-called storage is really in energy consumption. We reduce the amount of consumption that it takes to do the same kind of functionality. And so the batteries now work when they didn't work before. But frankly, we need a lot more electrochemistry kind of work. There's a lot of other things that we need to do as well. It's a hard area. It's a really tough topic. And so I think we need to put more and more rabbits on the track. I think we could do a lot better in that area. And I think the Johnson Controls of the world are going to be major players in that arena. So in terms of R&D programs, that's where I would put emphasis. And I've given that advice to the Secretary. I think we will see new initiatives in areas like storage.
Great. Last question.
Good morning. This is a related topic, but I guess maybe a little bit more specific. A question would be, I'm a big proponent of distributed generation, and I think one factor, as you just alluded to, is storage. Vehicle to grid technology. You used to hear about it a lot, and now, I'm sure it's mainly the bottleneck might be on the storage side, or it might be on the control side. It seems like there would be controls to handle it, and there are some at some levels of development. But can you speak at all to vehicle-to-grid technology in terms of the commercialization in the near future?
Sure, we have a big project on vehicle to grid. We've got 20 Toyota Priuses that we have on campus as an experiment with our new energy systems integration facility. It can be a big piece. I'm not sure how it'll play out, to be honest with you. I haven't given up on hydrogen technologies. I haven't given up on a variety of other things where I think there's infrastructure challenges that they have. But it's early in the game in terms of changing our mobility profile. In terms of kind of what are the drivers, the biggest thing that's happening in vehicles these days is the autonomous vehicle. I mean, the amount of control that these vehicles can have is dramatic. So we're actually putting together some new initiatives that we're going to propose to the Secretary regarding, we got a big thing called DRIVE. It's got an acronym, it's kind of catchy. But essentially it is about autonomous vehicles with vehicle to grid, with a variety of things that really relate to how do you make it more sustainable, can you have continuous charging, that sort of thing where you're driving down the road and it's charging your battery. So all of a sudden now that takes a lot of the demand or the burden of the battery doing everything kind of by itself off of the battery and puts it into an infrastructure kind of thing. All great concepts. Google and others are actually leading the way. Beyond what the national programs are doing. I think the national programs need to get back in front because I think there's really some great innovation to be had there. It's infrastructure related. I'd like to do some experiments at our facility that are on the transport side, just like we've done on the building side. We've got our building campus is going to be really state of the art in terms of all the things that can relate to how do you measure, monitor, and how do you export all this new information into the broader marketplace. I'd like to be able to do something like that on transport because I think it's the piece that's getting left behind. And yet it's the piece where I think we're most vulnerable because we have very few options. So we need a diversity of fuel sources, electricity being one of those. Haven't given up on what those need to look like, but major wholesale changes there. And the OEMs are pretty much like the incumbent, and the oil companies are pretty much like the incumbents in the electricity business. So there's a lot of parallels. Important topic to continue